Good evening. My name is Rishabh Mishra, currently working with a virtual classes at Solapur Center. I am a JEE Physics faculty. I have a 3+ year of teaching experience, and today I am going to record a demo lecture. Before I start my topic, I need to teach some convention related to that topic, and this convention is from current electricity. So I am going to teach some convention related to topic, and there are three convention. Out of three convention, first convention is for resistance. First convention is for resistance. So what is the conventions? The convention is, let's suppose here we have one resistor. Which resistor have a resistance R? This resistor have a resistance R. This end is P and the other end is Q. Okay, and the current is flowing in the resistance from P to Q. This is the direction of current from P to Q, the I current flowing through the resistor. So convention is that if I move in the direction of current, if I move in the direction of current, the potential, if I move in the direction of current, the potential will decrease, and this potential is decreased by I into R. How we get this I into R? With the help of Ohm's law. Ohm's law tell us the potential decrease in a resistor is, or the potential change in potential in a resistance is I into R. So we get this rule with the help of Ohm's law. So the first convention is if I move in the direction of current, the potential will drop. And how much the potential is dropped? This potential is dropped by I into R. Again, if we move in this direction from Q to P, that means in opposite direction of current. In opposite to the direction of current, if I move in the opposite direction of a current, so our potential will increase. Always remember, resistance is the only element. If we move in the direction, resistance is the only element in which current is flowing from high potential to low potential. In resistance, current is always flow from high potential to low potential. In resistance, always remember the current is flowing from high potential to low potential. And this is possible only for the resistor, not for the other device. Resistor is a resistor is a device which consume the potential. So just come to the convention. If I move opposite to the direction of current, if I move opposite to the direction of current, my potential will increase, and this potential is increased by I into R. How I get I into R? With the help of Ohm's law. Ohm's law tell me my potential is changed by I into R. Okay, then let's come to our second convention. And second convention is for battery. Second convention is for battery. What is the convention? Let's suppose the battery is given like this. This is the high potential terminal and this is a low potential terminal. Here is the P, here is the Q. ठीक है? Okay. Then this terminal is a high potential terminal and this potential is a low potential terminal. We all know that. And the potential difference of a resistor is E. Sorry, the potential difference of a battery is E. Let us assume the potential difference of the battery is E. So if we move in the direction, we move from P to Q. If I move from P to Q, we are moving high potential to lower potential. If I move from P to Q, I am moving from high potential to low potential. So if I move high potential to low potential, my potential will decrease. By how much potential will decrease? Potential is decreased by the potential difference across the battery. The potential decrease is equal to the potential difference across the battery if we are moving from high potential to low potential. If we move in this direction, if we move in this direction, that means if we move from Q to P, Q to P, that means we are moving from low potential to high potential. If I am moving this direction, that means I am moving from low potential to high potential. If I go from low potential to high potential, our potential will increase. If our potential is increased, the question is how much our potential is increased. This potential is increased is equal to the potential difference across the battery, and the potential difference across the battery is E. This is our second convention. Now I'm going to teach the third convention. The third convention is for resistor. Resistor we already discussed. Third convention is for capacitor. Third convention is for capacitor. Okay, the third convention is for capacitor. So listen to me very carefully. Let's suppose there is a capacitor plate. This is the one capacitor plate. This is the other capacitor plate. These are the parallel capacitor plate. This point is P. This point is Q. Okay. Suppose this plate have positive Q charge. This plate have negative Q charge, and the capacitance of the capacitor is C. The capacitance of capacitor is C. Now, what happened? Suppose, suppose we are moving from positive charge to negative charge. If we are moving from positive charge to negative charge, that means we are moving from P to Q, then our potential will decrease. How much our potential is decreased? Our potential is decreased by our potential is decreased by Q by C. How I get Q by C? We know that the charge on capacitor is equal to C into delta V. So the potential change in the capacitor is equal to Q is divisible by C. That's why I write the same thing here. The change in potential is Q by C, and if I am moving from positive to negative charge in the direction of positive to negative charge, that means our potential will decrease. How I get how I get if I move from positive to negative charge, my potential will decrease. Listen to me very carefully. Listen to me very carefully. Let's suppose this is one plate of the capacitor. This is the another plate of the capacitor. Suppose this plate have positive Q charge as seen in the diagram. This plate have positive charge, so I draw this plate as a positive charge. Again, the other plate have negative charge. This is the other plate which have the negative charge. This has the positive Q charge. This has a negative charge. So in this, we know that the direction of electric field is always from positive charge to negative charge. Direction of electric field is always from positive charge to negative charge. We know that if we move in the direction of electric field, our potential will decrease. Already we study in the electrostatics. So if I move in the direction of electric field, my potential will decrease. Okay. How much my potential is decreased? By Q by C for the capacitor. So from here we get that how our potential will decrease if we move from positive charge to negative charge. Just reverse it if we move in opposite to the electric field, opposite to the direction of electric field. So we are moving from low potential to high potential. So if we move from low potential to high potential, if we move from low potential to high potential, our potential will increase. How much our potential will increase? Increase by Q by C. Our potential is increased by Q by C. This is the case. These are the three conventions which I used for my topic. Okay, now I'm going to start my topic. Today's my topic is about the Wheatstone bridge formation in capacitor. Wheatstone bridge, Wheatstone bridge in capacitor. We already study, we already know about the Wheatstone bridge in resistor. Now we are going to read the topic, that is Wheatstone bridge in a capacitor. So there are two types of question in it. Two types of Wheatstone bridge formation is. First one is balanced Wheatstone bridge. Balanced Wheatstone bridge. So how the valence Wheatstone bridge is defined. Let's suppose here we have capacitor of capacitance C1. Okay. Here I have another capacitor with capacitance C3, and again let's suppose here I have a capacitor of capacitance C2. Okay, here I have a capacitor of capacitance C4. Okay, now here I have another capacitor of capacitance C5. Okay, let's suppose this point is A point, this point is B point. Now I am going to join these 2 points. Now I am going to join these 2 points with a battery. So, according to the definition of balanced Wheatstone bridge, it is defined if C1 by C2 is equal to C3 by C4. If C1 by C2 is equal to C3 by C4, then it is a formation of balanced Wheatstone bridge. Balanced Wheatstone bridge. Okay, balance Wheatstone bridge. Okay, so if the Wheatstone bridge is balanced, then the point A and B, these both point A point and B point have same potential, have same potential. These 2 points, A point and B points, have same potential if C1 by C2 is equal to C3 by C4. These four follow if C1 by C2 is equal to C3 by C4, then this is a balanced Wheatstone bridge. And if it is a balanced Wheatstone bridge, then these point A point and B point have the same potential. And if B and A point have same potential, then again the charge at the fifth resistor is zero. Charge on fifth resistor C5 is 0. This Wheatstone bridge is also similar to the resistor. Okay, if the charge in this resistor is 0, so we remove the C5 capacitor charge. So we remove C5 capacitor. Okay, Now I'm going to take one question based on Wheatstone bridge. So the question is what? The question is just like that. Let's suppose here one capacitor. Now again, now again here one capacitor. Here one more capacitor. Okay. Here let's take one more capacitor. This is like this. This is one capacitor. Okay. Mm, this is wine with a battery. Okay. And this is also going to join battery. Let's suppose 100 volt. Now again from here we have one capacitor just like this. Let's suppose this is 100 microfarad capacitor. Sorry, 10 microfarad capacitor. This is also 10 microfarad capacitor. This is 20 microfarad capacitor. This is 8 microfarad capacitor. And let's suppose this is 40 microfarad capacitor. And this is X microfarad capacitor. So this is our diagram of the question. And the question asked is find just a part of the question. First part, find value of X. Value of X so that charge on 8 microfarad is 8 microfarad capacitor have 8 microfarad capacitor have zero charge. Zero charge. That means zero charge. That means if if this 8 microfarad capacitor have a zero charge, that means these 2 points, these 2 points have the same potential. So if these 2 points have same potential, we can remove 8 microfarad from this circuit. So if I remove this 8 microfarad from this resistor, these two capacitors become series. These two capacitors are in series connection. So for the series connection, I will solve 10 into 10 is divisible by 10 plus 10. This is the C equivalent of the series combination. I use a formula C equivalent is equal to C1 C2 is divisible by C1 plus C2. As this result we use many times we use this result. So this will come out to be 5 microfarad. Now the second part of the question is find charge on each capacitor. We are going to find out charge on each capacitor. Okay, so first we solve the first part of the question. So for the first part of the question, if I do C1 by C2 is equal to C3 by C4. If charge on 8 microfarad capacitor is equal to 0. If charge on 8 microfarad capacitor is 0, so C1 by C2 is equal to C3 by C4. This connection must follow a Wheatstone bridge formation. So C1 is how much? Is 20. C2 is how much? 5. C3 is how much? C3 is how much? C3 is 40. And C3 is 40 and the C4 is X. So X is equal to, from here we get X is equal to 10 microfarad. This is the value of X. Okay, now I am going to solve the second part of this question. So for the second part of this question, we need to find out the charge on each capacitor. I am going to redraw these this same diagram. So so according to this same diagram, these are the one branch of the circuit, and here is the second branch of the circuit. So I'm going to draw the same diagram just like this. Just like this. Here is one capacitor is 2 microfarad, sorry, 20 microfarad. 20 microfarad, and another capacitor is here. Another capacitor is here, and let me draw some clear diagram. So one capacitor is here, one more capacitor is here, and these lines are going like this. This is 20 microfarad, this one is 5 microfarad, and other twos are 40 microfarad and 10 microfarad. This is 40 microfarad capacitor, and this one is 10 microfarad capacitor. Okay, we need to find out the charge on each capacitor plate. So this is the power supply through the battery, and the battery is 100 volt. 100-volt battery supply the charge to these capacitor. So to solve this type of question, how we solve this type of question, uh, I will use the point potential technique. How I use point potential technique? This point has 100-volt potential. So this point has 0 degree, 0 potential. Okay? 0 volt potential. That's okay. This is the terminal. We gave a 100 volt to this terminal, then 0 volt to this terminal. This will transfer here 100 volt, here 0 volt. Okay. Okay, now I need to find the charge on each plate of the capacitor. So first for the lower part of the capacitor. So C equivalent, these two for the lower portion, these two are joined in series. So I need to find out the C equivalent. The C equivalent is equal to 5 into 10 is divisible by 5 plus 10. That is equal to 50 by 15. 50 by 15, and that is equal to if I divide by 5, there is a 3 and there is a 10. This is the 10 by 3 microfarad. This 10 microfarad, this is the C equivalent of lower portion of the circuit. Lower portion of the circuit had C equivalent. This lower portion of the circuit had C equivalent is equal to 10 by 3 microfarad. So this is the C equivalent. We know that Q is equal to C equivalent into delta V. One more information, we know that if these two capacitor are in series combination, then they have the same charge. If these two capacitors are in series combination, then these both capacitor have same charge, and that charge will be Q is equal to C equivalent is 10 by 3 into delta V is 100. So that is equal to 1000 by 3 microcoulomb. So let me write down the charges. These plate है uh, this plate है plus 1000 by 3 microcoulomb, and other plate is minus 1000 by 3 microcoulomb. This is the charge on this plate. And for next plate, how much? Plus 1000 by 3 microcoulomb. This plate have minus 1000 microcoulomb by 3. Then 1000 by 3 microcoulomb. How I get 1000 by 3 in this plate? The reason is these two plate, see very carefully, these two plate are isolated plate. These two plates are isolated plate. And the definition of isolated plate is charge in sum of charge initial is equal to sum of charge final. The the summation of initial charges and the summation of final charges are equal. So if we see initial charges on these two plates, this is 0, this is 0, then the initial charge is 0 plus 0 is Q initial charge, sum of two charges. So if we are going to sum the final charges on these two plates, we get the same result 0, and we are getting 0. Look, these plates have minus 1000 by 3 microcoulomb. Then these have the plus 1000 by 3 microcoulomb. And when we add these two, we get a 0. That is equal to Q initial. This is the definition of isolated plate. So with the help of the concept of isolated plate, we find out the charge on these two isolated plate. Okay, okay. I'm going to find out the charge on the upper part. So for the upper part, how we get upper part? So for upper part, C equivalent is equal to 20 into 40 is divisible by 20 plus 40. This C equivalent is equal to 4 2s are 8, 00, and this is 60. This is the cancel out. So the C equivalent is equal to 40 by 3 microfarad. It's okay. Okay, I'm going to find out the charge on these two plate. So Q is equal to C equivalent into delta V. So charge on the upper plate is equal to 40 by 3 is the C equivalent, and this is multiplied by 100. That is the potential difference across the battery. So charge is equal to Q is equal to 4000 is divisible by 3 microcoulomb. This is the charge on the upper part of the capacitor. So I'm going to write down the charge on the upper part of the capacitor. So in this plate, we get plus 4000 is divisible by 3 microcoulomb. Other plate minus, if these two plates have same magnitude charge but opposite in nature. So this plate have minus 4000 by 3 microcoulomb charge. Again, there is a next plate, and for next plate, we get plus 4000 by 3 microcoulomb charge, and another plate have minus 4000 by 3 microcoulomb charge. Look, these two plate of isolated plate, so the summation of charges initially and finally are same. Okay, this is the isolated plate. These two plates are isolated plates. Okay, so look, we find all the charges on all the plates of the capacitor, all the charges at all the plates of the capacitors. Okay, so the first part and the second part of the question are solved. If let us assume the C part of the question, if they ask charge flow from battery, let us assume the C part of the question. If they ask what is the charge flow from the battery, so how we find? Let's suppose the charge flow through the battery Q is equal to. So look, this Q is going from battery and deposit at this plate and this plate, because these whole sections are the isolated section. That means the charge cube is equal to 4000 is divisible by 3 plus 1000 is divisible by 3. That is equal to 5000 by 3 microcoulomb. So charge through battery, let's suppose C part, they are charged through battery. So charge through battery is equal to 5000 by 3 microcoulomb. This is the charge, this flow from a battery, and this charge is going to deposit on this plate and this plate. Okay, so we solve the question based on a valence Wheatstone bridge. Now I am going to solve. Now I am going to teach one very important topic, and that topic is unbalanced, unbalanced Wheatstone bridge. Wheatstone bridge. If the question comes from this topic, must be comes in the JEE Advanced. These questions are at the advanced level. So listen to me very carefully. Um, how we solve the unbalanced question based on unbalanced Wheatstone bridge. Let us assume one question. Let us assume one question. Here, here 2 microfarad capacitor. Let's suppose here we have 2 microfarad capacitor. Now again here we have 4 microfarad capacitor. Now suppose here we have we have now here we have 4 microfarad capacitor. We have 4 microfarad capacitor, and again here we have 4 microfarad capacitor. Okay, and in between these two we have one more capacitor, and the capacitance is 4 microfarad. And these two points are joined with a battery, and the battery, let us assume the battery have the potential difference, the battery have the potential difference of 100 volt. Okay, this is the question based on the unbalanced Wheatstone bridge, and the questions asked in this part of the first question asked first question first part of the question is find charge on each capacitor, charge on each capacitor. And the second part of the question, find find what we have to find C equivalent between, let's suppose this is the point P, this is the point Q, between P and Q. This P and Q are the 2 points, and we need to find the C equivalent between these both points. And the C part, total charge, total charge flow through battery, through battery. So these are the three parts of the question based on a unbalanced Wheatstone bridge. We need to solve these three parts. So how we solve these three parts? First, we are checking the Wheatstone bridge formation, because here we get a 5 capacitor. If C1 by C2 is equal to C3 by C4, then the formation of Wheatstone bridge is confirmed. So 2 is divisible by 4 is equal to 4 is divisible by 4. So here 1 by 2 is equal to 1. That is not correct. If this is not true, so that means it's a unbalanced Wheatstone bridge. Wheatstone bridge. So how we are going to solve, how we solve this question based on unbalanced Wheatstone bridge. Let's see. So I copy the diagram and paste it here. I'm going to solve this question. Listen to me very carefully. How we solve this question? We will solve this question same as we solve the circuit question of the current. How? I'm assuming that I'm assuming that X amount of charge is coming from here. If X amount is charge from coming from here, then X amount of charge is going from the battery also. And this X amount at the junction, this X amount is divided in two parts. Let's suppose in the upper part of the circuit, Y coulomb charge is flowing. Upper part of the circuit, Y coulomb charge is flowing. Then the lower part have how much charge? X minus Y. Lower part have X minus Y. So at the upper part, plus Y minus Y is deposit on a 2 microfarad capacitor. Again, here is a junction. So at junction, let's suppose the Z Coulomb charge is going through the middle part of the circuit, middle part, that means passing from the 4 microfarad capacitor, and other remaining, that means Y minus Z is going in this way. So plus Z is deposit on this plate, and minus Z is deposit on this plate. Again, Y minus Z at these plates and minus times of Y minus Z at this plate. Um, coming Z is coming from here and X minus Y is coming from here. So this plate have X minus Y charge and this one have plus X minus Y charge and another have minus X minus Y charge. Okay, and this plate have X minus Y plus Z minus times of x minus y plus z charge. These are the charges at the these are the charges at the plates of the capacitor. Now we have to find the value of x, y, and z. Okay, now I'm going to find the value of x, y, z. We have a two rule to solve this question. First one is loop rule. First one is loop rule, and second method to solve this question is nodal analysis. Nodal analysis or point potential. So I'm going to solve this question with both method. First, I solve this question with the help of loop rule, and again I solve the same question with the help of point potential or nodal technique. Okay, so first we solve this question with the help of loop rule. Okay, let us take these these three plates are isolated plate. Okay, okay, let we again draw this isolated plate. First I apply the first loop rule here, first loop. Here is my second loop, and here is my third loop. Why I'm taking a three loop? Because we have a three unknown, x, y, and z. For three unknown, we need three equations. To solve these three and to find these three unknown, we need a three equation. That's why I am applying the loop rule three times. Okay. Okay, in the first loop rule, I'm going to start writing from here. So if I go from here to here, what I get x minus y and the capacitance is 4. So here I write x minus y x minus y is divisible by 4. Again, if I am going from here to here, I am going in this loop. So when I pass from here, then I write x minus y is divisible by 4. Okay. And if we are going from here to here, on this capacitor, we will write plus y is divisible by 2 microfarad capacitor. Again, here one more capacitor, and at this capacitor, we will write plus z is divisible by 4, that is equal to 0. Okay, now I'm going to take a LCM. The LCM is a 4. If the LCM is 4, this x minus y, this plus 2y minus z is equal to 0. Okay, so x minus y minus z is equal to 0. This is the equation number 1. We find this equation with the help of loop rule. Okay, in the first loop, we get these points. In second loop, loop number second, if I apply a loop rule in the second, how I get? I am going to start my loop rule from here, and I will complete this loop. The starting point and the end point is same for the loop. So when I cross this capacitor, so I get a charges are as x minus y plus z is divisible by 4. Again, I get a capacitor, I get another capacitor from here to here, and the value is z. So I write plus z is divisible by 4. Again, in this loop, I get one another capacitor. So the charge, the value of charge is the value of charge, the value of charge is where I am going from plus to minus. So I am getting minus y minus z is divisible by how much? 4 microfarad. That is equal to 0. Now I'm going to solve the equation. So the LCM is 4. If the LCM is 4, then x minus y plus z minus y plus z is equal to 0. That means 1x and y. These both are the minus. That means minus 2y plus 3z is equal to 0. This is the equation number 2. Okay, I apply a loop rule in a circuit for a 2 times, and now I'm going to apply the same loop rule in third loop. So for the third loop, this is the third loop. This one is the third loop. Okay, so I'm going to start applying a loop rule in this, and I'm going to start from here. So if I start from here and going here, here, then here, then here, then just like this. So I get 100-volt battery, and I'm going from low potential to high potential. That means I am going in opposite to the direction of electric field. So my potential is decrease. How much my potential is decrease? Same as the potential difference across battery, or how much the potential difference across the battery? That is sorry. My potential will not decrease. My potential will increase because I am going from low potential to high potential. If I'm going to low potential to high potential, my potential is increased. How much my potential is increased? As equal to potential difference across the battery, and the potential difference across the battery is 100 volts. So my potential is increased by 100 volts. So what I need to write here 100 volt. Next, I got a capacitor plate. So from here to here to here to here. Here I got a capacitor plate. I am going from plus to minus. So I write minus sign, and what are the charges? Minus x, x minus y is the charges, and the capacitor of the plates is 4. Again, I got another capacitor plate. I'm going from plus to minus, and here is x minus y plus z. So here I write x minus y minus z, sorry, x minus y plus z is divisible by 4 and equal to 0. So how we write? We write x minus y is divisible by 4 plus x minus y plus z is divisible by 4. When I transfer these two physical quantity from left hand side to right hand side, these both become positive. That is equal to remaining 100 in the left hand side. So again, I'm going to solve this question. So 4 is the LCM and we transfer the 4 to the right hand side. And the equation will become 2x minus 2y plus z is equal to 4 into 100 is 400. This is the equation number third. So from the loop rule, from the three loop, we got a three equation. Now, what we need to solve these three equation to find the value of x, y, and z. If we solve these three equation, we get the value of x, y, and z. So how we solve these three equation? Let me write this equation again. The first equation is x minus y minus z is equal to 0 is the first equation. And the second equation is x minus 2y plus 3z is equal to 0. This is the second equation. And what is the third equation? Third equation is 2x minus 2y plus z is equal to 400. This is the third equation. Okay, this one is the second equation. This one is the second equation with the help of second loop rule, and with the help of third loop rule I got the third equation. So how I am going to solve? First I want to eliminate x. So equation 1 plus equation 2 become 2x and minus equation number 3. So the x is eliminated. So how I got the answer? X plus x, that is 2x minus 2x. Again plus minus y and minus 2y, that is minus 3y, and minus minus become plus, that is plus 2y. Okay, and next equation is, this is minus z, this is plus 3z, this is become plus 2z and one more z, that is equal to plus 3z. So plus 3z is equal to 0 plus 0 minus 400 is equal to minus 400. Okay, so x is cancel out. For the y, we get minus y plus 3z. Minus y plus 3z is equal to minus 400. Okay, let's suppose this is the equation number fourth. This is the equation number fourth. Okay, I'm going to find again the equation number fifth. So how I get the equation number fifth to solve the question? To get the equation number fifth, what I'm going to do? I'm going to do um, equation first minus for equation first minus equation second. If I minus the equation first with the equation second, x and x are the cancel out, and y plus 2y is equal to next z minus 3z is equal to minus 4z is equal to 0. Okay, so from here we get y is equal to 4 times of z. Y is equal to 4 times of z. This is the equation number fifth. Okay, this is the equation of fifth. Let fill the color. Let fill the color. Okay, this is the color which we like. Now again I'm going to solve one equation to find. Okay, put the value of y. Put the value of y in equation number fourth. Put y putting the value of y in equation number 4. So if I put the value of y in equation 4, that is equal to minus 4 times of z plus 3 times of z is equal to minus 400. Okay. So, so for 300, for this value of z, how we get minus z is equal to, that is equal to minus z. Uh, just wait a second. How we solve this equation? If y minus 4z, this equation is correct. Equation 1 minus 2. So x and x are the cancel out. Y plus 3y. Y plus, sorry, y plus 2y. 2 plus 2y minus y is plus y, and minus z minus 3 plus minus 4z, that is equal to 0. So y is equal to 4z. So if I put y is equal to 4z, so minus 4z plus 3z is equal to minus 400. So z is equal to minus z, so z is equal to 400. That is, let us solve once again. I will erase these two equations and I want to solve it again. Let me solve it again. I think something is wrong. Now to solve this equation, what I am going to do, I multiplied equation number first with 2 and subtract with equation number third. So first multiplied by 2, that is 2x plus 2y, 2x plus 2y, and again minus 2z, 2z, that is equal to equation number first, equation number first, y is x minus y. How we get this x minus y? Divisible by 4 minus y by 2. Okay, okay. I do here a mistake, a small mistake. This is not plus, this is a minus y by 2. And if this is the minus y by 2, what we mean, this is also a minus and this is also a minus, then this become minus 2y. This become minus, no, not 2y. 2y minus y, that is become minus 3y. Okay, so let us change this equation with minus 3y. So here we replace the y. There was a small mistake in plus and minus. So our equation is not correct. Let me solve it again. Let me solve this equation again. So what we are doing? Equation first plus equation second minus equation third. We need to eliminate the x. So what we get? Minus 3 minus 2, that is minus 5, minus 5 plus 2, minus 5 plus 2, that is equal to minus 3y. Okay, again in the z, minus z plus 3z. Okay, this z and this z are the cancel out, and if both are the cancel out, this is the minus and this will also become a minus. So minus and minus become a 2z, minus 2z, and 3z. This is a 3z. So this will become plus z. Okay, and that is equal to how much? A minus 400. This is the equation number fourth. Now this is the equation number fourth. Okay. Now what I am going to do? Equation number 2 is multiplied by 2 and minus times of equation number 3. Okay. If I multiply the equation number 2 with a 2, I get 2x minus 4y minus, sorry, plus 6z is equal to 0. Again, the equation number 3 is 2x minus 2y plus z is equal to 400. Okay, so this plus become minus, this minus become plus, this plus become minus, and this plus become minus. These both are the cancel out. If these both are the cancel, if these both have to cancel out, then what I get here minus 2y, okay, and here plus 5z, and that is equal to minus 400. Okay, so look equation number 4, and suppose this is the equation number 5th. Okay, equation 4th and 5th. Now what I'm going to do? Multiplied equation number 4 with 5, multiply equation number 4 with a 5 and minus equation number 5th. Okay, if I multiply equation number 4 with a 5, what I get? 5 into 3, that is minus 15y, plus with a 5, that is 5z, and that is equal to minus 5 4s are 20,000, sorry, 2,000. This is the minus, and the minus equation number 5th is minus 2y, that is 2y, 5 3s are 15, and minus 2y. Okay, minus 2y plus 5z is equal to minus 400. So this will become plus, this will become minus, and this will become plus. Okay, so this is cancel out, and minus 15 and plus 2 become a minus 13y. That is equal to how much? Minus 1600. So y is equal to 1600 by 13 microcoulomb. This is the charge. This is the value of charge, y charge. So from the help of this, we need to find out the value of x and z also. So if I put the value of y in one of these equation, I will get the value of z. So what I am doing? I am put the value of y. I am putting the value of y in equation number 5th. Okay, I am putting the value of y in equation number 5th. So how I get minus 2 into what is the equation? First I write the equation, minus 2y plus 5z is equal to minus 400. Okay, so this is minus 2 into y is how much? 1600 is divisible by 13. Okay, plus 5 into z is equal to minus 400. Okay, 16 to the 32. 16 to the 32. So 5z is equal to minus 400 plus 3200 is divisible by 13. Okay, again, if I will cut this 5 with this, become 80. This 5 6 are 30. 5 4 are, this will become this. Now again we solve this equation. That is equal to how much? Minus 80 into 13 plus 640. 640. 5 4 are 32 0. Okay, 640. And this whole is divisible by how much? Whole is divisible by 13. Okay, so if I solve this equation, how much I get? 80 into 30. So 80 into 30, how much I get? 80 into 30, 80 into 30. mm, 80 into 4, 30. So if we multiply this 80 with a 13, let us multiply this 18 with 30. So how much of I get? 170, 103, 102. So with the 8, 107. Sorry, 104. Okay, 104. So how much I get? How much I get? I get minus 1040 minus 6, sorry, plus 640 is divisible by 13. So Z is equal to how much? Z is equal to how much? This is equal to minus 400 is divisible by 13 microcoulomb. This is the value of Z. Okay, we get the value of Z. Now, again, if I get the value of Z, if I get the value of Y, I will put the value of Y and Z in the equation number first to get the value of X. So, by putting, I'm saying put the value of Y and Z, putting the value of Y and Z in equation number first. Okay, and what is the equation first? The equation first is x minus 3y minus z is equal to 0. X minus 3y minus z is equal to 0. X minus 3y minus z is equal to 0. So x minus 3 into y is how much? Y is 1600 by 13. 1600 by 13 minus value of z is minus 400 by 13, and that is equal to 0. So the value of x is equal to 4800 by 13, and this become minus, that is 400 by 13. So the value of x is equal to 4400 by 13 microcoulomb. So we get the value of x, we get the value of y, and we get the value of z. So if we get the value of all these three x, y, z, we are we are in the picture to tell all the charges on these plates. So how we define the charges on each plate? This unbalanced Wheatstone base. This is the unbalanced Wheatstone. This I need to take a I need to copy this diagram, and we need to write down the charges on each plate. So if we need to write down the charges on each plate, how we write the charges on each plate? Uh, at the upper plate. Let's suppose first we write the charges on upper plate. In upper plate, we have the two capacitors. First is 2 microfarad. 2 microfarad has Y amount of charge, and the value of Y is equal to how much? 1600 by 13 microcoulomb. That is 1600 by 13 microcoulomb. Okay, so at this we have the plus 1600 by 13 microcoulomb, and this plate have minus 1600 by 13 microcoulomb. Okay, and next upper plate is how much? 4 microfarad. 4 microfarad have how much the charge is? Y minus z. Okay, the value of y is 1600 by 13, and the value of z is minus 400 by 13. That is minus 400 by 13. So that is equal to 1600 plus 400 is equal to 2000 by 13 microcoulomb. This is a charge on 4 microfarad capacitor, and that is equal to plus 2000 by 30 microcoulomb minus 2000 by 30 microcoulomb. Okay. Again, on this 4 microfarad capacitor at the lower end, how we find at the lower end? Now, after upper, we will find at the middle part. So for the middle part, we have plus Z. For the middle part, we have a one capacitor as a 4 microfarad, and that capacitor has Z, and that Z is equal to minus 400 by 13 microcoulomb. Now again, come to the lower part of the capacitor. At the lower part, we have a two capacitor. Lower left part 4 microfarad capacitor have how much charge? Have x minus y charge. So the value of x is 4400 by 13. That is 4400 by 13. Okay, minus y. The value of y is how much? The value of y is 1600 by 13. That is 1600 by 13. Okay, if I minus 4400 with a 1600, I will get 2800 by 13 microcoulomb. So charge on this plate, this is the plus Z is minus 400 by 13 microcoulomb. Sorry, this is plus and this is minus 400 by 13 microcoulomb. Okay, and again on the left 4 microfarad capacitor है, this have the plus 2800 by 13 microfarad capacitor, sorry, microcoulomb charge, and this have minus 2800 by 13 microcoulomb charge. Now one more plate is remaining, lower part, right side, 4 microfarad capacitor. So at 4 microfarad capacitor, how much we have the charge? Uh, at 4 microfarad capacitor, right 4 microfarad capacitor have x minus y plus z. So in the right side, in the right side, 4 microfarad capacitor, how much charge we have? X minus y plus z. X minus y plus z plus z. This much is the charge, and the value of this charge is, the value of x is 4400 by 13 minus the value of y is, the value of y. How much the value of y? Y is 1600 by 13 minus 1600 by 13 plus value of z is minus 400 by 13. Okay. Okay. This become a 2000 or 244,000 minus 2000. How much? How much if we minus a 2000? This will become 2400 is divisible by 13 microcoulomb. So charge on these plates are plus 2400 by 13 microcoulomb and minus 2400 is divisible by 13 microcoulomb. This is the charge on this plate. Okay. So we write the charges on each plate, on this upper part, in this lower part, and also at the middle part of this capacitor. So this is the one of the method to solve the unbalanced weight issue. In this question, we use the loop rule in this question. Okay. So if they ask charge through a battery, so that amount is x, and the value of x is how much? The value of x is 4400. So value of x is how much? Value of x is equal to, value of x is equal to 4400 is divisible by 13 microcoulomb. Okay, this is a charge through battery, and we also find the C equivalent, but I will find the C equivalent after I solve the same question. After I solve the same question with the help of point potential technique. Now I am going to solve this. Now I'm going to solve this same question. Now I'm going to solve this same question with the help of point potential technique. This is the question. This is the question, same question. and I'm going to solve the same question with the help of point potential technique. Method number method number 2. I'm going to solve this question with point potential technique. Okay. So how I solve the point with the help of point potential technique? Let's suppose there is a point, okay, and this point has the potential V1, and if the potential V1, so let us assume there are three plates, and these three plates are isolated plate, isolated plate. What we mean with what is the meaning of isolated plate? Summation of initial charges is equal to the summation of final charges are equal. The summation of initial, the sum of the charges at the initial condition, and is equal to the sum of charges at the final condition. Okay. So, okay, let's suppose from this the there is a the current is flowing, or the charge is flowing, sorry, the current is flowing I1. From here the current is flowing I2. From here the current is flowing I3. So with the help of point potential technique, or with the help of junction rule, what we write with the help of junction rule? I1 plus I2 plus I3 is equal to 0. Sum of the current leaving the junction is equal to sum of the current approaching the junction. Okay, this is the concept. After integrating this, after after integrating with respect to after integrating with respect to time, after integrating with respect to time, we get di by dt. So di1 by dt is equal to q1. This will become q2 and this will become q3, and that is equal to 0. Okay. We know that we know that summation of C delta V is equal to 0. How I write C delta V is equal to 0? There is a Q, or Q is how much? C into delta V. Then the summation of charges equal to 0. That means the summation of C delta V is equal to 0. Okay. 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 Next, how we write summation Q1, Q2, and Q3. If I need to write the Q1, so how much I write? The potential difference across this is V1. That is V1 minus. Suppose this potential at point P we have 100 volt. At point Q we have 0 volt. So for the upper part, V1 minus 100 is divisible by 2 microfarad. Okay. Again, V1 minus this point is V1. Let's suppose this point is V2. So V1 minus V2 is divisible by 4. Okay. And the next one is, sorry, charges V minus V2 is equal to C into delta V. I will write like this. I need to write the charge now, and the charge is C into delta V. So for C into delta V, for first one, C is 2 microfarad, and this is V1 minus 100. V1 minus 100. Okay. Plus C2 is how much? 4 microfarad capacitor. V1 minus V2. And next one is how much? Q3. Q3, how we write the Q3? Plus 4 into V2 minus 0 is equal to, whole is equal to 0. Okay, I need to solve this question. This will become 2V1 minus 200 plus 4V1 minus 4V2 plus 4V2 is equal to 0. Okay, 4V1 minus times of 4V2 is equal to 0. So how the question will solve? So V2 will be to cancel out. V2 and V2 will be cancel out. How the V2 and the V2 will cancel out? It's okay, 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 okay. There is not V2. This is the V1, and this will also become V1. Okay, this is the V1 now. We will write for this capacitor, we will write V1. For this capacitor, we will write V1 minus 0, V1 minus 0 into capacitance. That is V1 minus 0, and the capacitance is 4. And this is become a 4V1. By mistake, I write here 2. That was my mistake. Again, going to solve this question. 2V1, 4V1. That is a 6V1. And this one is also 4. And 4, 6, how much? 10. 10V1. This will become how much? 10V1. Okay. Again, this 10V1. This is V1, and the V2. V2 is how much? 4. So minus 4 V2. And I move a 200. I move this 200 from left hand side to right hand side. It become positive and become 200. Now I'm going to divide left hand side and right hand side with a 2. So this will become 5 times V1 minus 2 times V2, and this is equal to 100. This is the equation number first. Okay. In the same way, I'm going to use the same technique at point V2. So I use the same technique at point V2 at the lower end. At lower end, summation of what we write? Summation of what we write? The summation of C into delta V. The summation of C into delta V. This is equal to 0. Summation of C delta V is equal to 0. So how we write? For this 4 microfarad capacitor, V2 minus 100, that is 4 into V2 minus 100. Again, for next 4 microfarad capacitor, plus 4 into V2 minus next one is how much? 0. V2 minus 0, and one more is 4 microfarad. For this, V2 minus V1 is multiplied by 4. So how I write? 4 into V2 minus V1, and that is equal to how much? That is equal to 0. How I'm going to solve this question? 4 times of V2 minus times of 400, and this will become 4 times of V2, that will become plus 0, and next one is 4 times of V2 minus 4 times of V1, that is equal to 0. So what we get? 4V2 and 4V2, 8V2 and 4V2, that is equal to 12V2. So here we write 12V2. Okay. So how much V1 is? 1 V1, only one V1 we have. And this V1 is minus 4 times of V1, that is equal to how much? 400. I am going to divide with a 4 on the left hand side and the right hand side. So how much become? This become the 3 times of V2. This become minus V1, and that is equal to that. Sorry. How? 4. I am dividing with a 4. So this is become a 100, and this is become a equation number 2. So here we have a two equation number first and equation number second. I need to solve these two equations and find the value of V1 and V2. If I find the value of V1 and V2, easily I can solve the equation, because if I know the potential difference and the capacitance, with the help of potential difference and capacitance, we will write the charge on the capacitor. That's why we are finding the potential difference, or the value of potential, that are the value of potential is V1 and V2 with the help of point potential technique. So how I find? I am going to going to multiply 5 with equation number 2 and subtract, no, add with equation number first. I multiply 5 with equation number 2 and add with equation number 1. So what are the values? If I multiply equation number 2, it will become 5 3s are 15 V2 minus 5 times of V1, and add with the equation number 1. that is 5v1 minus 2 times of v2, that is equal to, multiplied with a 5, it will become 500, and add with a equation number 1, that is 100. Okay, so from here v1 will cancel out, and 15 v2 and minus 2 v2 become a 13 v2, and that is equal to 1600. So the value of v2 is equal to 1600 by 13 volt. This is the value of v2. Now similarly, I am going to find out the value of v1. How I am going to find out the value of v1? I will put the value of v2 in the equation number first. Equation number first. Put the value of v2 in equation number first. If I put the value of v2 in the equation number first, we will get the value of v1. So the equation first is 5v1 minus, equation first is here now, and in equation first we will get 5v1 minus 2v2. 5v1 minus 2v2. So how we write? How we write 5v1? Here we write 5v1 minus 5v1 minus 2v2. 5v1 minus 2v2, that is equal to how much? That is equal to 100. Okay, so put the value of v2 in this equation. So 5v1 minus 2 into how much? 600 by 13 is the v2, and that is equal to 100. That is equal to how much? 100. So 5v1 is equal to 100 plus 1200 by 13. Okay, this has become a 1200 by 13. Okay, so from here what we get? 5v1 is equal to 1300 minus 1200 is divisible by 13. Okay, so 5v1 is equal to 5v1 is equal to how much? This is the plus, this is the plus, and this is the plus if 1200 and 1300. This will become 2500 is divisible by 1300. Sorry, 2500 is divisible by 13. So we get the value of v1, and the value of v1 is equal to 500 by 13. This is the value of v1. So I get the value of v1, also I get the value of v2. So how we solve? With the help of v1 and v2, how we find the charges? Let's see. Let's see how we get the charges. Just I want to copy the question. Okay, here we have the question. This is our question. Copy, and I'm going to paste. I'm going to paste here. Okay, this is the question. So this is the question. So the value of v1 here, the value of v1 we get how much? The value of v1, this is the 500 by 13 volt, and the value of v2, how much? Value of v2 is 600 by 13, 600 by 13, and the potential of here is 100 volt, and the potential of here is 0 volt. These are the potential. With the help of this potential, we will write the charge on each capacitor. First, I will write the charge on upper part of the capacitor. Upper left is 2 microfarad capacitor. So for 2 microfarad capacitor, we need to write down the charge. So Q is equal to C into delta V. Okay, the value of C is 2 microfarad, and the delta V is 100 minus 500 by 13. That is equal to how much? 1300 minus 5. That is 800 by 13. 800 into 2. That is equal to 1600 by 13 microcoulomb. These are the charges. This will become plus 1600 by 13 microcoulomb, and this will become minus 1600 by 13 microcoulomb. Okay, these are the charges on 2 microfarad capacitor. Again, we need to find out the charges on a 4 microfarad capacitor. So how we solve? 4 microfarad capacitor, 4 microfarad capacitor is equal to charge on the 4 microfarad capacitor is equal to C into delta V. The value of C is 4. Okay, and the potential difference we will write 500 by 13, 500 by 13 minus 0, that is equal to how much? 2000 is divisible by 30 microcoulomb. So at 4000 microfarad capacitor, the charges are plus 2000 is divisible by 30 microcoulomb and minus 2000 is divisible by 30 microcoulomb. These are the charges on 4 microfarad capacitor in the upper part of the circuit. Now at middle part, for the middle part, how much we have? Middle part, the capacitor at 4 microfarad capacitor, and charge on it is equal to C into delta V. The value of C is 4, and the value of delta V is how much? 500 by 30. I will write down this like this, 500. No, I will write it down. 600 by 30. 600 is greater than 500. So minus 500 by 30. Okay. This is equal to 400 by 30 microcoulomb. So I'm taking a 600 by 13 as a positive and 500 by 13 as a negative. So the positive plate have, this plate have, a lower plate have the positive charge, and that is equal to 400 by 13 microcoulomb, and the upper one has, lower end have a positive charge and the upper end have the negative charge. This will become minus 400 by 13 microcoulomb. This charge at the upper end, because the potential of the lower end is greater than the potential at upper end. That is the reason. Now we are coming out at the lower end. So for the lower end, how we solve this question for the lower end? For the lower end, this is the 100-volt battery. We know that the potential difference. First we solve the left 4 microfarad capacitor. For left 4 microfarad capacitor, the charge is equal to C into delta V. C is equal to 4 into delta V. The value of delta V is how much? 100 minus 600 by 13. That will become 4 into 1300 minus 600 is divisible by 13, and that is equal to 4 into 600, that is become a 700 is divisible by 13, that is 2800 is divisible by 13 microcoulomb. 2800 by 13 microcoulomb. So we get a charge on this lower part at the 4 plus 2800 by 13 microcoulomb and minus 2800 by 13 microcoulomb. These are the charges at the lower plate of the capacitor. Okay, one more plate is remaining. This plate, lower side, right hand side, lower right hand side, right hand side capacitor, and 4 microfarad capacitor. How much charge this have? So the charge is Q is equal to C into delta V. So Q is equal to 4 into delta V is how much? 600 minus 600 by 13 minus 0. Okay, so Q is equal to 2400 by 13 microcoulomb. So how we write this? Charge on this plate is 2400, that is positive, by 13 microcoulomb, and this plate had minus 2400 by 13 microcoulomb. Okay, these are the charges on each plate. So if we need to find out the charge through the battery, so charge through the battery is how much? These the charges which are stored at this plate and at this plate is coming out from battery. The charges at this plate and this plate is coming from battery, and that is equal to how much? That is equal to 1600 by 13 plus 2800 by 13, and this will become how much? 13 is the LCM. 28 plus 16 will become 44. That will become 4400 by 13 microcoulomb. So in part C they ask total charge flow battery. So the answer of part C, total charge through battery, charge through battery, and this is charge through battery is a total charge, and this is equal to 4400 is divisible by 13 microcoulomb. Okay, in the next part of the question, in the second part of the question, they will ask the C equivalent. How we find the C equivalent? Actually, if I replace this all capacitor plate with a single capacitor, and this will become like this. This is the single capacitor, and the value of capacitance is C equivalent. The value of capacitor is C equivalent. Okay. Now the value of potential difference across battery is 100 volt. Let's suppose this, and the charge is coming out from a battery is how much? Is 4400 is divisible by 13, and these charges are going to deposit on the plate, on the C equivalent plate. So this have the plus 4400 by 13 microcoulomb. Okay, and this will become a minus 4400 by 30 microcoulomb. So these are the charges on the plate, on this plate. So what we need to find out the C equivalent. We know that Q is equal to C equivalent into delta V. We know both the charge Q and the delta V. The charge Q is how much? These are the charge which are coming from the battery, and delta V is the potential difference across the capacitor. So the value of Q is 4400 is divisible by 13 is equal to C equivalent, and the delta V is 100. So this from this 100, just 20 are the cancel out, and the C equivalent of the capacitor is 44 by 30 microfarad. This is the this is the answer of second part of the question. So we solve all the parts which are asked in the question. How we solve? We solve this question with two method. The first method is loop rule. So from the help of loop rule, we apply a loop rule in this. We apply a loop rule in this. We apply the loop rule in this. From here we get a one equation. From here we get a one equation. From here we get a one equation. So first equation, this is the second equation, and this is the third equation. So with the help of first equation, second equation, and third equation, with the help of all these three equation, with the help of all these three equation, with the help of all the three equation, we find out the value of x, the value of y, and the value of z. With the help of x, y, z, we get the charge through battery and charges on the each plate of the capacitor. Okay, and after that we use the nodal analysis or the point potential technique or the junction rule. For this rule, what we have to do, we have to assume that the potential of these 2 points, these are the first, these are the second point, these are the 2 points have the potential V1 and V2, and from the point V1 the current V1, V2 and V3 are going out, or similarly from V2 is the current is I1. From here the current is I2. From here is current is I3. And all these three plates are the isolated plates. So I1 plus I2 plus I3 is equal to 0. How we write? With the help of junction rule. So we get a one equation from here, one equation from here. After solving these two equations, we get the value of V1 and V2. If we get the value of V1 and V2, and we know the value of capacitance, so from Q is equal to C delta V, or Q is equal to C delta V. With the help of Q is equal to C delta V, we find out the charges on each plate of the capacitor. So if we find out the charges on each plate of the capacitor. After that, I replace these. After that, we find out the charge through battery, and this all charges is going to the C equivalent. The one capacitor. If I replace all these five capacitor with a single capacitor, and the capacitance of the capacitance is C equivalent, then the charge through the battery is going through this is 44,000 by 30 microcoulomb, and these all charges is deposit on this capacitor. We know that the charges, we know that the potential difference. Again, we use Q is equal to C delta V. We know the Q, we know the delta V. We will find the C equivalent, and the C equivalent it comes out to be 44 by 30 microfarad. This is the answer of all these questions. Thank you so much.